In this video, we're going to onboard the two remaining devices. These devices are going to be vEdges, and in order to be able to do that, we're also going to entertain the idea of implementation using a dynamic mechanism. So this means, again, I'm going to need a template. So what we're going to do is we're going to navigate back to the menu of the user interface. We're going to go to configuration, and we're going to go to templates. Navigate to device templates, and once again we're going to find ourselves presented with our non-default options. I intend to navigate to default options. I'm going to look for resources for vEdges using a filter. What we see here is I have a pre-existing default template for a SD branch deployment using a vEdge. Once again, this is going to be a default feature template, which means I cannot edit it. Ergo, I'm going to copy it. We will go ahead and just call it SD branch vEdge cloud template. I'm not going to worry about a designation on it. And I'm just going to simply change the description to a device template for SD branch vEdge cloud. I'm going to go ahead and hit copy. Again, this is going to create a duplicate of this template in the non-default section. So now I'm going to navigate back to non-default in the menu, and I'm going to get rid of my filter, and we'll see here that we have these devices. I am going to edit this because the name didn't come out right. I just want it to look right, so I'll say edit. And it's going to be, instead of an E, it'll be a capital D. All right. So from this resource, let's look at this, because again, there are going to be a few things that we need to be mindful of. So remember, every template, whether it's a cEdge template or a vEdge template, is going to be subdivided into different sections. Among those sections, we will always have a basic information section, a transport and management VPN section, a service VPN section, as well as an additional template section. Other devices may have other subsections, but bear in mind these are going to be the four that we need to balance on a regular basis, irregardless of the devices that we're working with. So in the basic information, I'm going to leave everything as default for the system config and the logging. I'm going to navigate to my transport VPN configuration, and what I want to see here is the fact that we are going to end up creating a default branch config for VPN 0. That's a template. So that's the only VPN I need, and I need at least one interface to be in VPN 0. And we see that we already have a feature template that is going to provide that capability. If I go to my VPN 512 template, we can see here I'm using a factory default VPN 512 template, and I'm using an internal management interface for this specific configuration or for this specific resource. So again, like I said, we're building a basic config. We'll note right here, I do not want any service-side VPNs. So we're just going to get rid of both of those and say remove VPN. Scrolling down, we're going to take a look at the rest of our configuration, and from first blush, it looks like everything should be good to go. I am kind of concerned about some of these templates. So let's take a look at some of these templates. So if I hit the down arrow and look at the nature of this template right here, this template is going to be for VPN 0, template VPN 1. That's good. Let's take a look at the interface template. So I'm going to take a look at the interface template, and that too looks also like it's going to be good. Next, we're going to turn our attention to the OMP template, because this is going to be another example where a default template can be dangerous. You will notice here that we're using a factory default feature template for OMP. And what I want to call your attention to here is that this is going to be working for IPv4 and IPv6. Now, this is the default template for this resource that we copied, the device template. So one of the things that I need to do is I need to change this, because we're not going to be running IPv6. If we were running IPv6, what would end up happening is that we would need to configure IPv6 interfaces and have all of the operations in place. However, since we're not doing that, if we try to apply this template, it's going to give us an error message. I don't want to have to go through that error message. So what I'm going to do is I'm going to hit the down arrow. And what we're going to find here is there's going to end up being another template, another default factory feature template for just standard OMP, removing the necessity for having to define any of the IPv6 criteria that was going to be used by the previous feature template. So right now, all I'm going to do is I'm going to go ahead and hit update, and we're going to see if we cannot get this to take those changes. We have the bootstrap for all vEdges. Now we have the software-defined branch vEdge cloud template that I made a copy of and modified. Now all I'm going to do is I'm going to associate a device with it. So I'm going to attach a device. The device that I'm going to attach is going to be 7AC29 ABF, etc. So I'm going to highlight this guy, put it into the selected devices column, and I'm going to hit attach. Now, as always, it's going to ask me to provide the missing information. I'm going to go ahead and I'm going to click the Edit Device Template and do this in a columnar style format just for clarity. So I have a VPN DNS primary, which will be 183.1.1.1. I'm going to have a secondary. We'll go ahead and make it 8.8.8.8. And again, this is because I'm using a default template. And I need to configure the next hop IP address for my VPN0 interface. Now, I happen to know based on my lab, so if we take a look at my lab right now, this device right here is going to be connected on Gigabit Ethernet 00, and the IP address is going to be 10.104, the site ID, 4.41, the device number, .2. And my gateway of last resort is going to be .1. So looking at that, that's going to be what I'm going to need to provide here. So that's what I am going to put in. So it's going to be 10.104.41.1. I'm going to go ahead and say IPv4 address prefix length for VPN v4. So that's going to be both of those pieces of information. So it's going to end up needing the IP address to be applied. I'm going to do 10.104.41.2/30 for that device. So again, I'll put my mouse on top of it. And that's going to be the IPv4 address that I'm going to be using. And hopefully that will be on Gigabit Ethernet 00. So we'll give that a try. I'm going to say host name is going to end up being SD Geeks vEdge 41. The system IP address is going to be 10.255.104.41. And obviously my site ID, third octet, will be 104. So let's go ahead and see if we can get this to apply. I have a green check mark. Now that I have a green check mark, I'm going to select next. Let's go ahead and see what configuration is going to be pushed to the device by looking at the configuration preview. Hopefully there will be no error messages. If there are, obviously we will address those, but I don't think there will be. And we can see the configuration commands that are going to be sent to this device. We've learned our organizational name because we configured the vManage. We see we are using VBond sdgeeks.local, which is again part of the vManage configuration. We can see that we are going to be configuring VPN0 with a primary and secondary DNS. Gigabit Ethernet 00, which is the default, is going to be using this IP address that we applied. And you'll note here by default that there are limited services that are going to be enabled, so we will not be able to SSH to that interface if we need to. And we'll also note here that I do have a default route that is going to 10.104.41.1, and this should be sufficient to the task with regard to configuring the device. However, remember, this device is not onboarded. Ergo, that means that the configuration is going to be attached to the device, and what will end up happening is we will get the message here again, like we saw in the previous video, that this is going to ultimately end up being scheduled. Then what I'm going to do is I'm going to need to do some configuration in the lab. So right now we see that it says that the template is scheduled to be attached when the device comes online. Now, the next thing I'm going to do is I'm going to navigate to the menu bar, to configuration, to devices. And what I'm going to do is I'm going to type into the screen vEdge for my filter. And we'll see here that I have a UUID that is pending synchronization, just like what we saw in the previous video. Now what I'm going to do is I am going to hit my three dots and I'm going to say I want to generate a bootstrap configuration. Now, we are running 20.9, so we leave this box unchecked. If we were running an older version that is going to be from 20.4x and down, we would go ahead and check that box, and that's just going to change the nature of the configuration file that's going to be generated. I'm going to go ahead and select OK. And right now, what I'm going to do is I want to pay some attention to some of the values. So right now, you'll notice that the UUID defined in this bootstrap configuration lists the UUID of the device. And it's also important to note that we have the OTP, which is the token. This is going to be demonstrated here after the contents : space field. Now, all I'm going to do is I'm going to use these pieces of information to be able to direct my device towards the zero-touch provisioning configuration that we're going to need to make, because right now the ZTP server is not ready. Now, what I'm going to do is I'm going to go ahead and close this. Now, you saw in the previous video where we were working with vEdges, we basically SCP'd those files to these resources. Understand that in the viptela world, the vEdge devices, what they're going to do is they're going to expect you to have an ISO. So we are not going to be able to do that, which is one of the reasons that full-on zero-touch provisioning is really not taught in a lot of the Cisco classes when it relates to implementing your configuration using any provisioning mechanism that would be dynamic. And we also need to understand what's going to be happening by default in our infrastructure. So what I'm planning to do right now, first and foremost, is I want to go to our vEdge. So what I'm going to do is I'm going to go ahead and navigate to vEdge 41. Let's close the, well, I'll need the business internet router when the time comes. And what we're going to find here is that I'm going to log into this device. Admin. It's going to ask me to change the password. ICE is cool. ICE is cool. And we can see that it took that password. Now, what I want to look at is I want to look at the default configuration for this device. I'm going to make this wider, just for clarity's sake here. And what I'm going to do is I'm going to say show run system. And what we're going to find is a vEdge, unlike a cEdge, by default is going to end up trying to communicate to a URL called ztp.viptela.com. Now, that used to be a resource that was maintained by viptela pre-acquisition, and it was their authentication servers. And Cisco basically removed that functionality and replaced it through the creation of devicehelper.cisco.com. But the problem is devicehelper.cisco.com was designed for the Cisco resources, not vEdge devices or viptela devices, physical or virtual. Now, since this is a virtual device, we have some problems because this device has no idea of what its UUID is, doesn't understand its token, it does not have a cryptographic ASIC. So we're going to have to emulate that behavior, which is going to kick off what we're going to refer to as our zero-touch provisioning process by using a request command. But we'll get there. If I say show interface description, we can see that this device does have an IP address. It has an IP address because the internet server is providing a DHCP address. So from the perspective of this device, before I do anything else, I want to make certain that it has the capability to be able to communicate to the outside world. I'm going to ping 8.8.8.8. Let's see if that works. And it does. I'm going to ping 10.10.1.11, which is the internal IP address of my vManage. And everything's going to ultimately end up being good to go here. But bear in mind, ztp.viptela.com doesn't exist anymore. And this device, by default, is going to be trying to connect to that resource. So if I say show run system again, we can see here that the system has No idea about its organizational name, its system IP address, nothing. It's a blank config. And by default, it's programmed out of the box to try to communicate to a resource called ztp.viptela.com. Now, what I'm going to do in my lab is I'm actually going to implement my own ZTP server. All right, it says system ready, so let's log in. Admin. ICE is actually, it'll be admin initially. ICE is cool. ICE is cool. All right, we can see that we have changed the password. Next thing that I want to do is, again, I'm going to say config, and we're going to go to the system and put in the credential information that's going to be necessary. So I need to have a host name, and I'm going to go ahead and call this PNP-ZTP. Next, I'm going to need to have a system IP, 10.255.255.99 for the 4th octet. My site ID is going to be 1. My organizational name is going to be Master Class. Remember, it needs to be placed inside of parentheses since it's going to have a space. The VBond is going to be it, and its address is going to be 10.10.199, and it will need to be configured as a VBond, and I'm also going to specify it as a zero-touch provisioning server. I'm going to go ahead and say commit. Transition over to VPN 0. I'm going to say DNS. It's going to be 183.111. I'm going to do an IP route that will be a static route that's going to point to 10.10.1.1 as my gateway of last resort. I'm going to say interface, gigabit Ethernet 0.0. It will need an IP address, and we said that IP address was going to be 10.10.1.1.99, and it's 255, so it's going to be /30. It's going to be a tunnel interface. Encapsulation will be IPsec, and I'm going to go ahead and say allow services all, and we'll say no shut, and we will say commit and quit. Now, as a result of this, let's see, gigabit 0 IP address. Oh, that's stupid. Need to fix that. My apologies. So we'll just up arrow. It's going to be /24. Commit and quit. There we go. Keep forgetting /24 in the shared services block. All right, so let's do a couple of pings. So 10.10.1.11, can I get to the vManage? Yes. Can I ping 10.104.41.2? And I can. All right, and ping www.google.com. And I can. So the only thing that I cannot do at this particular instance in time is I cannot ping ztp.viptela.local. Let's take a look at that. So from the perspective of this guy, I'm going to say ping ztp.viptela.com, not .local. And that is now no longer reachable because Cisco turned it off. So what we're going to need to do is we're going to need to create a way to bypass that. So what I'm going to do is I'm going to go to my business internet, and I'm going to configure this device. Since this device is my DHCP server, show run interface loopback 0, we can see that this is that IP address 183.1.1.1 that I'm using as my DNS server IP. So what I'm going to do is I'm going to type IP host, and it's going to be ztp.viptela.com, and I'm now going to tell this DNS server to send that to 10.10.1.99. I'll go ahead and say exit, and we'll write that so that it won't disappear from us. So it won't disappear if we screw something up. All right, so now from the perspective of this device, can I ping ztp.viptela.com? And yes, it's being redirected back to this device. So my last check is going to make certain that this device can ping that resource. So I'm going to say ping ztp.viptela.com. com. And we can see now it's being redirected to the right spot. Now, it's interesting because what I want to do next is I want to start taking a look at what's happening on this interface. So what I'm going to do is I'm going to right-click on Business Internet, and I'm going to start a capture operation using Ethernet 2.2, which goes down towards vEdge 41. I just want to kind of have this available in case we want to take a look at anything that's going to be transpiring on this link. So I'm going to go ahead and say Ethernet. Okay. And we can see we've got a couple of things going back and forth, ARP, some OSPF packets because it's configured on that interface. But just keep in mind that we have traffic that is being monitored now. Now, interestingly enough, what we're going to need to pay attention to here is now we have everything that we need to allow this device to connect to the zero-touch provisioning server, but the zero-touch provisioning server is not completely configured. So what I'm going to do is I'm going to go to my jump box. I'm going to navigate to my menu. I'm going to go to my devices under configuration. I'm going to advance to controllers. And what I'm going to do is I'm going to add this resource as a third VBond, but because it is not part of the fully qualified domain lookup, and it was not online at the time I built my SD-WAN configuration, it's not going to show up as a viable VBond. I'm going to add controllers. I'm going to go ahead and add my VBond. We're going to say it's going to be located at 10.10.1.99. It's going to be admin, ICE is cool. And what I want Cisco to do is I want Cisco to sign its certificate for me. Now, this is going to take some time because if you think back to our configurations and you go to your administration and you go to settings under the menu, if we were to take a look at the config that we have in place for our controller certificate authorization under Cisco, if I just click view, we can see here it's set for 5 minutes. So it could take as long as 5 minutes for this to actually get this certificate signed. So in the interim, we're just going to wait for it. I'm going to go to configuration. I'm going to go to certificates. I'm going to go to controllers, and I want to wait until I see that this has installed its certificate. So right now we can see here a VBond, a third VBond is showing up in our infrastructure, and it has submitted a certificate signature request for Cisco to sign for us. And again, this could take upwards to 5 minutes, but we will wait on it. All right, we can see that the certificate has been installed. We see the certificate serial number. We see the IP address, but we also do not see the host name and the system IP configured in this installation because this is going to be a ZTP server. Again, this is not necessarily the way that we would do this in a production deployment, but it is important to understand that I'm just taking the path of least resistance, and this is a way that you can get your ZTP server up operational with a signed certificate in your lab as is if you're following along with me now. I should be able to proceed. I'm going to sort on DTLS. All right. And right now we have none as of me just turning this on, but we've only received like 6 packets. Now, it's not going to start until I force the system to try to initiate communication. Now, what I'm going to do next is address exactly that issue. So again, we have a certificate that's installed. So the next thing I'm going to do is going to be to go ahead and I want to get my bootstrap configuration back up. So what I'm going to do is I'm going to go back to my WAN edge list. We'll go back to our vEdges as a filter, and I want to get that bootstrap again. So I'm going to say generate the bootstrap configuration, again, cloud init. And I'm going to go ahead and grab this piece of information right here because we're going to need to provide that to the device itself. So I'm going to go ahead and open a terminal. I'm not going to be able to SSH to it this way until I'll have to say show run interface show VPN show run VPN 0 interface gigabit Ethernet 00, and it's going to be blocking SSH. So I'm going to have to fix this real quick just so that I can get in there to solve my copy paste issue. You know what? Actually, I don't need to do that. So what I'm going to do is I'm going to open up a VBond. So with this guy down, the only reason I was going to have to mess with it was so that I could SSH to it, but I don't have to. What I can do is I can come over here and say admin ICE is cool, and I'll just pull the valid vEdges. So show orchestrator valid vEdges in a tabular format, and we can see right here this is going to be the UUID I'm going to use. I was going to pull it out of the graphical environment, but I chose not to. So now what I'm going to do is I'm going to say I want to do a request vEdge cloud activate the chassis number, and then I'm going to need to provide the token. And if we take a look at the VBond, I'll get my token right here. Okay, didn't mean to do it there. All right. So we've just punched that information in, and what I want you to see here is notice it's now started sending information directly towards 10.10.199. Information is traveling back and forth between 10.10.199, and again, this is a DTLS tunnel. Now, what I want you to see is it's going to be having communications back and forth between these resources. But what I want to do is I want to look at what's happening on the zero-touch provisioning server. Let's take a look at what's going on. So from the PNP server, we take a look at the PNP server's build. What we're going to need to pay attention to here is going to end up being the results of the vdebug. So I'm going to log into, as I showed you guys before, I'm going to go to vshell. I'm going to change directory to var log temp log, and then I'm going to say I want to do a tail -f because I want it to be a constant tail of the vdebug. And what we want to look at here is we want to look at what's going on. So notice it says we have a message right here. VBond rejected v connection severity major, says it's 10.10.10, but what you'll notice here is the UUID that we're being sent is the one that we configured. Organizational name is Master Class, service provider organizational name is, but what's happening here is it's saying the serial number is not present. So what's happening here is that this device cannot get onboarded. There's a constant back and forth communication between the vEdge and the zero-touch provisioning server, but the zero-touch provisioning server is not completely configured. It does not have the ability to be able to act as a ZTP server yet. The reason being is it doesn't have the ability to provide information to candidates. So what I'm getting at here is if I type show ZTP and I use my context-sensitive help, you'll see here I have a value for entries. And what's happening here is I have no entries available. So in other words, I am a zero-touch provisioning server because I said, make me a ZTP server when I configured the identity of the VBond as myself. And if I show orchestrator, valid, vEdges, you'll notice here I know about all of these devices. In fact, I'll just come over here and put it in a tabular format. So you see that I know about all of these resources. So these are my 4 vEdges and my 6 my 6 Catalyst 8KVs. But what we're going to note here is that I'm not configured to provide any services for these resources. I need to add them to my ZTP catalog. So what I'm going to do is I'm actually going to type request. I'm going to say device. I'm going to add a device, and the device that I'm going to add is going to be a chassis number, and it's going to be this chassis number right here. Next, what I'm going to do is I'm going to go ahead and say I need to add a serial number, which it will be using this serial number. Next, what I'm going to do is I'm going to determine whether or not, or specify a validity. So this is going to be valid. Remember how we had to go into the vManage and select valid or invalid to delete a resource or to use a resource. I also need to tell it the identity of the organizational VBond. The organizational VBond is going to be located at vbond.sdgeeks.local. Lastly, I need to tell it the organizational name. So I'm going to say the organizational name is going to be Master Class. Now, I'm going to go ahead and hit enter. And we successfully added that. So now if I say show ZTP entries, what we're going to see is it now has the necessary information to provide services to this specific and particular resource. Now, what I'm going to do is on the ZTP server, I'm actually going to go back into vShell, do a cat vdebug. And this file is huge, by the way, so it may take a little while for it to show up. Okay, so negotiation, hello tolerance, get, no side challenge sent because we don't have a cryptographic ASIC, but we did send an OTP config. And it should identify the resource. So I'm hoping that this is actually going to go through and it's going to provide all of the necessary information. So we have this idea of the serial number not present. But let's see what's happening from the perspective of the device now. Notice it says peer manage IP, public IP. That's going to be 10.104.41.2 and says its new state is up. So it did successfully form a peering relationship. So let's take a look and see what's going on, because right now it doesn't look like anything has been applied. I'm going to say show control connections. And let's see. We do have a connection to the VBond, but the VBond that we're connecting to right now is listed as being 10.10.1.99. So that's actually the ZTP server. It's not the VBond. So the one thing I wanted to check real quick before I go any further is to see if I didn't mess up the DNS. vbond.sdgeeks.com. .local, sorry. It's working already. We can see that it's working. vbond.sdgeeks.local. We can see that it's working because we're communicating over here. We have formed a DTLS tunnel to our vManage. Application data is going across. I want to exit out of this here. And I want to go ahead and hit enter here. And you can see that it's pulled its config SDG VE41. If I say show control connections, we should have a connection to the vManage. We have a connection to the correct vBond. Right now, we're waiting for our peering relationship to take place between our vSmarts. So we'll just simply wait for this. One of the things that I really detest about the vEdge devices is the fact that, one, they don't support any type of neighbor discovery protocol, LLDP or CDP. The other thing that I hate is that their output is not verbose at all. So there's no real indication on the screen as to what it's doing in the background. So the ultimate objective of this would be to form peering relationships with my two vSmarts, which we can see that we've done. And if you think back to the cEdge deployments when we were using the Catalyst 8KV, and as well as the CSR 1000Vs and the ISR 4331s that I used in the initial portion of the class, we could see very clearly that there was an ordered process because everything was going to the console on those devices. These devices don't do that. So to give this a test, we're going to say show OMP peers, and we should have peering relationships with up to 2 of our vSmarts. We can see that we have our DTLS tunnels that are going on. They're here on this guy, just show BFD sessions. So we can see here that I have IPsec tunnels that are, every one of these tunnels that I have are actually running an instance of bidirectional forwarding detection in them, like we discussed in our theory. So from the perspective of the jump box, if I get back into my console, and again, only reason I brought this up was I was going to copy and paste the token and the UUID out, and I chose not to. We can see that according to this, it says it's out of sync. So it is in sync. So again, like I said, in virtualization, especially using an internal Ubuntu server, it's not going to be the most robust tool we have available. We can see that we resolved the site ID. We are in sync. And the final check is going to be to go to monitor, to overview, and we should see that we have 7 devices that are reachable. And if I take a look at those 7 reachable devices, one of those devices is going to end up being SDG VE41, which is a vEdge in our environment. So the whole objective of all of this was to demonstrate the fact that we can do some bare minimal configuration to create a zero-touch provisioning server, as well as manually enter the information that I dumped in using the viptela license file previously. Ancillary to that, it's also important for us to keep in mind that there is going to always be that initializing configuration on a vEdge, where we have to go in and say request vEdge cloud, activate, and then the designation. Now, we could have done the exact same process and procedures with a cEdge. I just opted to do a full-on bootstrap configuration using Cisco Quick Connect. Actually, we didn't use Cisco Quick Connect. What we ended up doing is we just did a template-based configuration. Quick Connect does not work very well for vEdges. It works great for ISRs like I demonstrated, but for vEdges, I would not recommend you trying it. It has a tendency to hang, and it also locks you out of the console by default. So again, it's not something that I would advise you guys to do. But from a 30,000-foot look, we can quickly and easily see that what we've done is we've onboarded vEdge 41. Now, the next object is going to be to go ahead and onboard vEdge 42. vEdge 42 is going to be in Site 104, and I'm going to probably do that manually just as my last wrap up for this walkthrough. And again, we'll take care of some little administrative factors, and then we'll dive into our core conversations about our theory. I look forward to that conversation, and I'm hoping to see you guys in the next video.